From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. We have three fantastic guests on our panel today, and I have some spicy questions queued up for them. First off, we are joined by Michael Knight, president of the eXponential Technology Group and senior VP of corporate business development at TTI. You might remember him from last year as well. We have Jeff Newell, senior VP of products at Mouser Electronics, and Misha Govshteyn, CEO of MacroFab. This podcast is sponsored by Mouser Electronics, a global authorized distributor offering the world's widest selection of the newest semiconductors and electronic components. Well, I'm really excited for all of you to be here. Could you please introduce yourself and tell us a little bit about what you do? Michael, let's start with you.
Yeah, thanks, Daniel. Michael Knight, I'm the president of what's called the eXponential Technology Group, which is a group inside of TTI. We're a part of the TTI family of specialists focusing on all things semiconductors, special focus on connectivity, especially around IoT, automotive, that kind of thing.
Awesome. And Jeff?
My name is Jeff Newell. Thanks for having me. I work for Mouser Electronics, which is the catalog arm, online arm of TTI. And I am responsible for our global supplier and relationships and engagement, along with our tech support function, as well as all the pricing that we do relative to what customers see online and what we charge them to place orders.
My name is Misha Govshteyn. I'm the Chief Executive Officer of MacroFab. MacroFab is a cloud electronics manufacturing company. So we have everybody from engineers to very large corporations building electronics through our platform, and exclusive to North America. So we have a lot of customers using this for reshoring, but very software driven. So we have a lot of designs that are flowing through our platform and build a lot of product for customers.
Awesome. Well, I'm really excited for this. And we have to start with State of the Supply Chain 2022. It's been a couple years, and I think anyone in the industry knows it's been tricky. Jeff, the concept of distributed supply chain has been pretty trendy. Do you think the industry at large is making progress in that direction?
Slowly. Obviously we have been living through unprecedented times in the last few years relative to what's going on, not just in the electronics industry, but everywhere. The electronics industry, I think, has relied on supply chain technologies over the last 10 to 15 years. The biggest one was probably the just-in-time concept that has just gotten thrown out the window. I mean, it's just crazy how when everything is cut that finely, one little thing goes awry and it kind of throws everything else in disarray. So we're still living through that, obviously. I do see signs that things are getting better, but my belief is that suppliers, obviously distributors, and end customers are starting to think more about how do I have a robust supply chain, not necessarily a distributed supply chain, which really I think is going to cause a little more reliance on inventory, right? If we can't rely on just in time in today's environment and maybe in the future, and I know we'll talk about that in a little bit, I think having inventory available, having partners that are going to, back their customers up and do what they say, and having suppliers that are going to eventually have to have more capacity for an ever-growing demand for electronic components. I think that inventory importance will continue to resonate over the next few years, and maybe even longer than that. I mean, once all the capacity that suppliers are investing in comes online, that could change a lot of things. But I don't think that it's all going to come online in the areas where we're still having a lot of delivery challenges, extended lead times, et cetera, et
cetera. Yeah. So you mentioned just-in-time manufacturing and inventory. Michael, you had some interesting things to say about just-in-time inventory in last year's Industry Tech Days panel. Can you share if you've seen any progress or how people have adapted their strategies in the last 12 months?
Yeah. So to kind of build on some of the topics that Jeff covered, there are some signs of progress, but it's given the depth and magnitude of the problem, it's actually kind of amazing to me just how much today still looks and feels like this time last year and this time 2 years ago, et cetera, et cetera. And it's been a kind of a pet theme of mine. I feel like the whole electronics industry has moved into a new era. It's exponential growth. And through that, it's exponentially changing a lot of things in our lives. But one of the things that hasn't changed is how our supply chains operate, which when you think about them, most of these things were designed and built over the course of the last 50 years using a very kind of analog approach to growth, an analog approach to capacity expansion, and certainly optimized for cost as opposed to optimized for resiliency. So you had a lot of consolidation of things, which with climate change and global politics and things is obviously creating a lot of problems in the supply chain. So what I'm not seeing yet is this kind of mass realization that things are moving exponentially. And until such time as I think folks who are planning capacity expansion and building supply chains, operating supply chains, start thinking in those terms, I'm not sure that we ever get this fixed. So Jeff was talking about some things are getting better, no doubt, but there's a lot of things that aren't. And I think those are the kind of poster children for this thesis of mine, right? So microcontrollers, power semis, et cetera. The other thing that I think is going to be really important going forward is we have a lot of tools that should help us solve this problem and are going to help us solve this problem. So it's planning stuff, it's AI. There's a lot of big data things, and then there's to give a plug to MacroFab and Misha. There are new ways of approaching this, where kind of as a manufacturing as a service that I think are highly interesting. But the last point I want to make on this, then I'll shut up, is the one thing that I have not seen is, which I've been waiting for, is kind of the reemergence of the concept of component engineering, which once upon a time was where you went for multi-sourcing. The component engineer's job was to make sure you had multiple sources on every socket on a bill of material. And I hate to say this, but I still see far too many new customer projects come into us that only have one part number and one supplier called out on a given socket for a bill of material. And that just perpetuates the problem, right?
Yeah, having backups and designing with that in mind seems like it would be prudent at this point. Misha, can you share some of the trends you've seen in the last year in the electronics world?
Yeah, I probably have to declare my biases first, right? So when you talk about distributed manufacturing, I think we are distributed manufacturing, right? We have hundreds of production lines all across North America. We're very software driven. So I think our customers just work in a very different way. When you say things like, is just in time still a thing? It is still a thing for people that think they can outlast the lead times. Most people have given up on it and started to inventory their parts and buy well ahead and really start to treat electronic supply chain as a scarce resource. But to what Michael was just talking about, we're actually seeing a lot of people, because they're working in a software system, right? They're able to upload multiple designs, and we're starting to see a trend. The number is 3, right? 3 designs that essentially have, in some cases, just basic changes like footprint changes to some of the components. In some cases, literally a different BOM for very similar product, right? Functionally equivalent, but they're sourcing. They have a lot of variability in which BOMs they can maintain, and then it gets into an exercise of, hey, I need 2,000 units. I'm going to build 1,500 of that flavor and then 500 more of another flavor because that's what I can source. And I think software is filling the gap in a lot of those functions, right? So there are a lot of. This is what blows me away. My background is all cybersecurity and cloud. The level of software automation we see in the cloud world is just radically different than it is in electronics. Even things like GitHub, where you can easily see a diff between your designs, difficult to do with your supplier. With your supplier, you have no idea how much you have. If you're working with a manufacturing company, God help you if you need to figure out how many components you have and whether you're ready to go to production, whether your golden part is in stock. These are all very manual aspects of production, and this gets down to distributed manufacturing, right? When you work in the cloud, the first thing they teach you is, look, assume that it's all going to break and there's going to be a calamity, and design your system around the notion of failure. In electronics, it's been the opposite. It's been abundance economy, and it's been good, fast, and cheap, and usually financed by somebody else's balance sheet. So I think all of that is going to change. I think there's a humongous amount of value in electronics. That, I think, has been the sea change that Michael's talking about. People are realizing just how valuable this stuff is. So I personally hope a lot more people realize that the stuff that really moves the world, a lot of times it's in this industry, not necessarily in software, for which we pay for maybe too much, right?
So how have each of your companies adapted over the last year or 2 years strategically, architecturally, to address the kind of the new state of the world that we're in? And Jeff, let's start with you.
Sure. It's funny. If you go back to 2019, before the pandemic kind of changed everything, we were very much a book ship distributor, meaning all of our inventory was available. Engineers knew what we had. They came in, they placed an order, it shipped that day or the next day, and they got it, a day or two later. That's all kind of gone out the window. Generally, we don't have a lot of customer bookings that we're waiting to ship something because we had all the stock in place. Now we're waiting on the product coming from the supplier. So that's caused us to think a little bit differently about how we place orders on suppliers out in time. It used to be just for replenishment, and when lead times were stable, didn't have to be short, but if they were stable, we were able to do that. We've really had to get creative about, well, how much farther out do we need to go place these orders so that we can ensure parts are on the shelf and engineers can get everything that they want. The other thing is just expansion. I mean, our business has grown crazily, and we're just kicking off right now another expansion to the warehouse that'll be the biggest one ever, because there's always, it's a bottleneck issue. It's either a bottleneck of supply, or in some cases it could be a bottleneck of we don't have enough space to put the parts that we have on order. So we're making sure we get ahead of that bottleneck before that becomes a problem. But and then you have a couple things like the big ice storm in Texas last year or earlier this year. That was just chaos, and it was all hands on deck to try to help out. There was so much backed up demand. Our machine is really set up to maintain all the time, right? It's just something going all the time. But when you have 4 or 5 days where nothing happens and those orders are just piling up from around the world, when things finally, open up and trucks are starting to deliver parts and the warehouse is up and for business, we had just a mountain of orders to try to get through. And yours truly was in the warehouse full of parts. I mean, it was just chaos. Now, they didn't check my quality scores. At least no one told me I did a horrible job. So I'm hoping that I didn't deliver the wrong part to a customer order. But we've really had to be, get creative, find a problem. If there's a problem, find a solution, right? All hands on deck. We'll figure it out. Ultimately, just continuing to try to serve that design engineer to make sure everything that they want to choose from is on the shelf, on the web, easily to find, and, we ship it very soon.
Awesome. Michael, how about you?
So a lot of what Jeff talks about is similar to what my side of the business within TTI has been doing. We're I think I would argue with anybody. I think we're the best in the world at stocking components, and which was extremely important in the just-in-time part of the cycle. How the industry worked. And I think is even more important in the just-in-case mode that we've kind of moved into. So we've got a customer base covered both ways for customers who are trying to continue to run just-in-time. We stock ahead. We stock for the general market. We pay a lot of attention to what we call available to sell metrics in terms of optimizing them. But over time, what's happened is our inventory turns have dropped as a corporation, our inventory turns at the moment are under 2, which allows us to, in essence, provide an insurance policy to our customers when it comes to components. And then for customers who find themselves in the mode of, actually wanting to do just in case, we've got some really strong supply chain programs and supply chain experts that we will send in on a consultative basis to a customer to help design kind of the optimal supply chain for that customer. That involves, an inventory backstop and things like that. Trying to take out the unknown and the wild variability in component lead times. And then the last thing I would point to, this is a journey that I'm on. We have been adding in a lot of engineering resource into our business, not something that we're typically known for, but in North America alone, I now have 80 hardware, software, and firmware engineers who are helping customers with designs. And one of the things that we do is deliver a multi-source bill of material. And we will actually help a customer and then take that into manufacturing. In fact, another plug for you, Misha, we've got a couple that we're using the MacroFab platform to help a customer get into manufacturing. So it's a different approach. And I think it's what we're working on, I don't know if you call it distribution 2.0 or 3.0, 4.0, but it's the next version, more integrated, higher value prop form of electronic component distribution. And it's still in its infancy, right? But that's what we've been up to.
And then Misha, on the manufacturing side, what have you had to do and what trends have you seen?
It's messy, but I got to be honest with you. I love it. We're in wartime mode, and I think we're trying to build a very different model for how to build product and how to do manufacturing. Believe it or not, it's actually very difficult to do without a crisis. A lot of people don't realize that the reason why cloud and SaaS are dominant now is because of a 2007 recession. Before that, it was impossible to sell SaaS software. So I think this is actually a huge opportunity for everybody in the industry. So we went back to all of our distributors. We used to have 2 that we were integrated with at an API level. Mauser was one of them. We were barely using the APIs, to be honest. It was just easier when you order just in time and parts just show up, you really don't need the APIs. But guess what? Fast forward to literally 6 months after the crisis started, we have 6 distributors now that are API driven. And frankly, I'm not going to name any names. Not everybody's APIs are actually fully functional. So who gets the orders? It's the distributors with functional APIs. 85% of our purchases are now fully automated. The other change is, we're doing a lot more strategic sourcing. We have people scouring the world for components, and this is the stuff that 3 years ago would have made people just freak out. It's like, oh my God, are you buying from brokers? You know what? That's how products get built these days. Everybody's doing it, and if you're sitting there with like 90% BOM completion, there are things we don't advise customers to do, but they're still, pushing forward and sourcing. Frankly, maybe bad parts from Alibaba. Like these are things we don't suggest people do, but people are in desperation mode out there in some cases and making ill-advised decisions. But overall, in terms of the rate of change that we're seeing, way faster than it used to be, and it's been great.
So let's talk black market, gray market components then, because that is something I've seen where people are looking to maybe less typical sources for more obscure parts or things that are heavily backlogged. Have any of you seen that impact your own supply chains or your customers' supply chains and builds? And are there any stories you can share, maybe without naming names, but any stories you can share of black or gray market components working or not working?
Yeah, so one of the things I've been tracking is the independent, the growth in independent distribution. That's the polite phrase for it. And I think the big companies have actually gotten quite sophisticated right? And you can see it in their numbers. By all accounts, I would bet that that part of the market has more than doubled in 2022, and probably doubled in 2021.
I don't have any inside information. I'm just reading articles, but I think Smith and Associates went from like $1 billion to $3.5 billion in a span of a year and a half or two or something like that. And when you're dealing with those numbers, this isn't just pirate parts. These are major companies building things with gray market components, right?
Yeah, and so exactly. And I'm finding that OEMs have started factoring them the independence into their supply chain planning. Now, and I think this is what you were alluding to, Daniel, that there is risk about where are the parts actually coming from, and are they going to be supported? And one of the kind of core fundamental value props for authorized or franchise distribution has always been, we only buy parts directly from the component manufacturer, full stop. And TTI and the family of companies, Mauser included, we are religious about that. So when we actually deliver a part to a customer, there's zero doubt about whether it's an authentic part and whether it's going to be supported. That said, Misha, you talked to this very well. When you're desperate, are you going to get picky about the source of the life ring that floats by? Nope. You're going to grab a hold of it, and hope for the best. And by the way, there are still plenty of instances where what you grab a hold of sinks you. We've got lots of customers who have gone into the gray market and acquired material that turned out to be a problem. The last thing I will say about this, which I think is going to actually, in a way, have some interesting forward ramifications, is for the longest time, our e-waste went to China, right? We shipped that containers would bring goods over from China, offload, and then rather than deadhead them back empty, we fill them up with e-waste. And China took it, and what we come to find out is they would take it. There were very clever companies that are taking this stuff apart and recycling and putting the components back into the market. Well, China isn't taking our e-waste like that anymore. So I think that's going to, in a way, shut down some of the problems, which I think is kind of interesting. But at the moment, and I recently attended the SMTA, so I think I can say this with some authority. The only sure way to know you're not getting a counterfeit part is to buy it directly from the manufacturer or from the manufacturer's authorized reseller of that part. Nothing else is as rock solid as that.
Jeff, I saw you nodding in agreement. Any other tips or anything you'd like to reiterate on that front?
I agree with 100% of what Michael said, and I'm parochial about it. I come from the supplier side. I worked for TI for many years, and I just think, it's a matter of risk. I get why customers do it, especially in this environment. What other options are there? If I can find parts in the gray market, and I probably have a few favorite people that have, I've trusted over the years to not send me bad parts, it's a viable option. I think that suppliers are really rethinking their strategy around that as more and more of them have their own web stores. They figured out, wow, it's really hard to stop sales to, distributors in China that aren't authorized for my product because it's kind of open to everybody. I also think they need to take a really hard look at their engagement with the direct big CMs, the Flexes and Jables of the world, because that's where the volume goes. And, we all know that there's some that leak out the back door, whether it was an overbuy on accident or on purpose. I think there's a lot of good product in the broker market, et cetera, but it just comes down to a matter of risk. And, if you can mitigate the risk to zero by buying only from authorized distributors or the direct manufacturer, I think you're doing yourselves a favor. In this marketplace, It's just a matter of, hey, we got to measure the risk, and we got to ship parts, right? We got to ship volume. So if I can't find it through the normal source, I got to find it somewhere else.
But you know what I mean, because we're on the ground of actually building products. So, we deal with a lot of factories out there, and we deal with a lot of products and SKUs, and obviously a whole lot of components. It's absolutely best practice to buy from the authorized distributors. And if we were in a normal situation, that would probably manage out vast majority of your risk out there. But it's not exactly what we're seeing these days, just because there's scarcity everywhere, right? So,
right.
And again, this isn't naming any names, but we ended up with product failing because it was capacitors that were literally dead on arrival from a authorized distributor, and we called them up, and I don't think it's their fault. These are pretty pedestrian parts. So, and to be honest, it's really hard to figure out exactly how this happened, but I can see a scenario where normally parts that would have been discarded somewhere because the quality controls call for it made their way to something that an authorized distributor ended up carrying. And there's a lot of pressure on people now to meet targets and fulfill demand, right? People are begging in some cases for materials, right? So what it goes back to is what I was advocating for earlier, is that we got to get away from this thinking that if we buy from authorized distributors, things will always work 100% of the time. Look, at the end of the day, we got to plan for these kind of failures. We got to fund engineering and testing, and in some cases, just really good forensic process to validate the authenticity of these components. We don't spend nearly enough time and money on this. It doesn't get funded. There's a lot of, I come from the cybersecurity industry, so now that I'm not in it anymore, I can finally speak the truth. There's a lot of money being spent on, frankly, kind of silly threat vectors that really never hurt anybody in a meaningful way. The supply chain is riddled with this stuff, and we don't spend nearly enough money on it. And that has nothing to do with where you source it from. You should just assume that if you get components, you should have some kind of process for validating the authenticity, and somebody's got to pay for it, and that's got to be baked into the product. And right now, it's not, right? That's not part of the assumption and costs for most designs, and it should be, right?
So I'm curious, Misha, if I can ask you a question. Would you suggest that suppliers be a little more open about lot code, date code, so that you could easily look at, all right, this is what I just got from the distributor or the supplier direct. Can I bounce it off the site the supplier maintains so that they can tell me, yep, that lot code, date code tracks, you're good to go?
I think having access to a lot of that information programmatically would help a lot, and that way you can report the problem and kind of maybe save the headache for everybody else. So
right.
Sharing that data would be of huge benefit. But again, most of who we're talking about here, right? We're talking about factories that are actually placing these components on boards for all intents and purposes offline. That's one of the reasons I find edge computing a fairly comical topic, because so many of these factories are so badly offline. And when it comes to what actually happens within that factory, it doesn't matter whether it's cloud or edge. They're just not wired enough to actually be aware of what's going on at a production level. But yeah, I think better data sharing would help quite a bit. And I think actually it's the investment in engineering, right? I think software engineers, you've seen what happens with salaries of software engineers. That inflation really hasn't happened in the electronics world, and that still indicates to me we undervalue this kind of work. Right?
From my perspective, if I'm ordering parts from a mouse or a TTI, I expect that those will be authentic and that they've been traced through to the original manufacturer. Can you talk about what your process is for authenticating and making sure you do have legitimate parts beyond just we ordered it from the manufacturer?
I think, Jeff, our answer is going to be the same.
I'll go first, because my answer will be short.
One voice here.
We don't, right? Our process is we only buy direct from the manufacturer. Now, there is a rare exception to that. If we buy a connector assembly, we don't have that capability ourselves. Sometimes we buy it from TTI. They assemble connectors for us. And there's a couple times where we'll buy it from a company like Powell, right? But we know who they are. We know what franchises they have. And we verified that they are going to only buy the piece parts direct from the manufacturer. That's it. That's all we do. And we ensure that on the backside as well, if we're getting ready to scrap some inventory that happened to be excess or what have you, we'll either send it back to the supplier via their rules, or we'll just grind it up ourselves and throw it away, right? We do not sell product into the broker market because, again, we don't want to be part of that problem, right? We want customers to trust. If we have parts on the shelf from name any supplier we have, it's come directly from them. We know how to care and feed it. We know how to take care of it. It's all, humidity controlled, ESD controlled, et cetera, et cetera, et cetera. So the customer doesn't have to worry about it. Now, will there be bad parts from time to time? Absolutely. Happens, I won't say all the time. It's getting less and less, but there will be times where, customers find that the part's bad. We've got an entire FA process going back to the supplier directly to check on some of that stuff. Sometimes the supplier has got bad lots. They didn't know it, right? Thank you for the heads up. We're going to go, fish out the rest of that and get rid of it. Sometimes the customer used it out of spec. And, it's kind of a TBD for that. But we don't have a process to validate what the supplier is sending us outside of 2D barcodes. We do a lot of the, that type of information to make sure the PO checks, the block code, date code are all on there. We store that in our systems, et cetera. But that's it.
Component manufacturers have, in a lot of cases, very sophisticated ways to trace this. Like, my personal experience, we got quite a few reels that looked suspect, and we sent them in. And I was blown away by how quickly it happened. And then again, going back to my past life, FBI got involved way faster into this counterfeit situation than I've ever seen them get involved in any sort of cybersecurity shenanigans. So I think we reported it on Monday. By Wednesday, they were in their hands, and by Friday, they had them X-rayed and validated that these didn't, the lot codes didn't match, and these came out of Taiwan and should have come out of China. We had the whole thing figured out, and returned the materials and destroyed the counterfeit parts. So our team was able to intersect that. Now, those points where you actually become aware of that, there are enough of them. Are people paying enough to actually scrub down the authenticity of the components? People just don't pay enough for it, right? It's
right. It's
not on anybody's top of the list.
Yeah, and that's what I'm glad you mentioned that. That's what I've been thinking about is, thankfully, we don't have to make the investments in X-ray machines and scanning electron microscopes and the other things to validate the parts that we're acquiring, because frankly, there's just not enough margin in this business for that. One of the things that comes along with being an authorized or franchised distributor is our margins more and more are very closely managed by the component suppliers, and there's a lot of cost that's on top of what we do that, to Misha's point, we can't pass along. The customer doesn't see any value in terms of traceability, data storage, and it goes on and on and on, right? To add this on top of it would be too much at the way the pricing and margin model works for the industry.
And you wouldn't be able to do it in all cases, right? Like in this
Correct.
case, this was as close to like an episode of CSI as I've been to. These were FETs, and they were functioning. They were functioning just fine. We wouldn't have been able to figure that out. We figured out the lot codes didn't match, but in the lab for the manufacturer, they figured out these are high-powered FETs. They fail in some operational conditions. There's no way a distributor can ever figure that out, right? That's not a practical expectation.
I would love to hear more about that offline sometime. We can maybe talk a little more freely. But I do want it to keep us moving. One of the big trends I've seen and we've been hearing about a lot is Industry 4.0 and how factories are becoming more and more connected. So, Misha, can you talk a little bit about what you're doing at MacroFab to move manufacturing forward?
Yeah, not to get into the terminology, because I still trying to figure out what Industry 4.0 means exactly, but I do think that there's still a ton of work to be left to be done in order to truly wire up the manufacturing world and make sure that it's visible and manageable in real time through programmatic interfaces. I think that's really what the battle is going to be fought and won in a lot of ways. And I'll give you just a very quick practical example. We interviewed a guy that runs a fairly large electronics factory for a large OEM, and he runs SAP, and I asked them, was like, look, I know what's going on now. Like, you get, SAP or any MRP today, right? They assume you're going to order some materials. Materials are going to show up in boxes. You open up a box, there is a expected number of parts in it. It's like, but that's not really the way it works anymore. You get boxes half filled, and like they'll give you what they can, right? So like, is your MRP designed for that? He said, no, you got it. It's not designed for that. So how do you manage it? It's like, well, he's got a really extensive spreadsheet right next to his SAP implementation. And what that means is that even if they wanted to get real-time data and visibility into what's going on in that factory, they can't, right? The real heartbeat of what's going on in that factory, whether you can do a line load and actually have all the materials in hand, it's not an SAP. It's on a spreadsheet somewhere. That's just a vignette to kind of help you understand just how disconnected things are. So I think ultimately, there's still a ton of work to be done in order to understand how much inventory do you have? And I know I'm talking about basics, right? Can you actually go to production? Is your next shift going to run out of material, right? These sound like pretty simple issues. They were simple in the peacetime, when you had just-in-time manufacturing still work and the supply chain was predictable and reliable. And right now it's not, so it's exposing all these fault lines. And what that means is that we got to build more and better software, right? And we got to design it for failure. We got to design it for real-time access. So I actually don't think and by the way, there's still tons of investments. Like if you look at Foxconn, and Foxconn is investing a lot of money into robotics to make sure that COVID doesn't take them offline again. They would love to eliminate people in the factory, but that's not the problem we're focused on. We're focused on making sure that we can, we know exactly what's going on in the warehouse, on the floor, and every factory that we work with, and we give customers real-time access into it. I think that's going to be one of the biggest breakthroughs, right? Right now, that data is not real-time and accessible, but we're pulling it forward, kicking and screaming, and it's working.
Awesome. Jeff, I don't think, or for anyone, I don't think I really need to emphasize the importance and the prevalence of IoT. But Jeff, I'm curious if the growth in IoT has changed how you think about both what you're stocking and also how you work with customers looking into the future.
Yeah, I mean, it's funny. The two key pieces of an IoT system today are a microcontroller and a sensor, and those are two of the hardest things to get right now. So IoT is still alive and well, but we are also looking at more, what I'll say, higher end products. Instead of just components, we're starting to look at more board level, more solution type stuff in the IoT space, in addition to the connectivity. For us, connectivity is kind of a greenfield because our customers generally are the design engineers who can design something. But more and more, we're working with suppliers to stock some of their Wi-Fi, Bluetooth, cellular-based products and figuring out how to make it easy for the customer to connect that to the provider, right? So that they don't have to worry about, okay, now how do I go get this thing connected to a cell signal or an internet, whatever. We're trying to do a lot of that for them just to make it easy. And it's really challenged us a little bit because it's not our core competency, right? We're in the business of shipping things that you can touch and feel. And when that becomes, selling something that's a little bit more amorphous and it's connected, and how do you measure, the value of that? We've been having to get creative with suppliers, and we're finding some ways to do that. Again, trying to make it easy for that customer to say, okay, I'm going to buy 100 of these things. Can you tell me how I can get connected easily so that I don't have to worry about it? I just want to pay you for that, and then boom, it works, and I'm off doing my next thing. I do want to say something, though, about the things that Misha was talking about. Even in our own warehouse, and I could see supplier warehouses all over the world, more and more, they are way more automated, a lot more higher end, and I think it becomes the COVID thing, whereas, when a fault in your process is exposed, you really try to go fix that problem and then fix it forever. Even in our own warehouse, being understaffed in the warehouse is a problem because we have a lot of throughput every day. I see more and more technology getting put into a warehouse, whether it's connectivity or things that can take the place of a person every now and then. And I think that trend will continue for a while. I mean, we are starting to stock and promote a lot more industrial automation, factory control type products, along with the components that we stock, because we just see a huge opportunity in that as everybody tries to make their business more automated and less reliant on people. I don't think you'll ever get rid of the people per se, but if I cannot have to hire as many, that's probably a better longer term solution.
Can you share any specific examples of where you've brought in robotics or AI to improve a process?
Sure. We have a lot of different things that we stock, and so the pulling of those products is very different, right? It could be an oscilloscope, or it could be a reel of capacitors, right? Things that you can hardly count, they're so small. We've tried to find ways to bring the inventory to the operator versus having them walk around the warehouse. The throughput is much faster, and you need less people if you can bring the inventory to them. The latest thing we've done is in consolidation. So our process, when someone orders a 10-line order, that has to come back together and get boxed up together to be able to fulfill that customer's order. And that process used to be very manual, and we found a way with technology to have it be very, very automated. So the quality is much higher. There's less chance for something to go awry and a bag fall out of the box because some of the stuff doesn't weigh much, and when the box moves fast, the wind just kind of takes it out. And we think it'll give us a lot more throughput where we could we're processing 70, 80,000 lines a day. We believe that we can do it with much higher quality and with about half the people with the piece of technology that we've implemented versus how we used to do it in the past. There's still people there. It's just that we don't have to go hire a lot more that are getting harder and harder to find.
Okay, awesome. Thank you. Michael, I've got kind of a tough one for you. Prices seem to be going up. There's inflation. And when I think about like my economics 101 course, you have the supply and demand curve and price in the middle. And are we seeing, like, as supplies are increasing, is the demand decreasing, or are we in this state where things may just be a little more expensive in the future? And maybe what are some of the factors that contribute to that?
Yeah, so there's not a one size fits all answer because depending on the type of component, if we're going to talk just about components, it's different case by case. What we're finding today is where a lot of the pressure in terms of availability is coming from is in legacy technologies, especially in semiconductors. Call it 20 nanometer processes are larger, and so what's happened is real underlying demand has increased. I think at this point that's you can't question that, and it's being driven by content in automotive. It's IoT that we were talking about. A lot of these high growth electronic rich environments are heavily dependent upon legacy technology still today. And the way the economics work on this is those legacy technologies are nowhere near as efficient, aka profitable, for the component manufacturer. So that's not where the greater part of their investment in capital for capacity expansion is going. It's going into the latest and greatest stuff where they can get $3,000 a wafer instead of $700 a wafer, kind of a thing. So that exacerbates the problem, and it makes it very messy and very confusing for the purchasing profession who's got to kind of sort through all of this. There is no one size fits all. So to directly address your question, I think what we've seen post-COVID is a rebalancing of pricing, taking into account margins companies need to invest in capacity to support kind of an exponential increase in demand. That the just-in-time thing had given the purchasing community a lot of opportunity and time to build this muscle group that was designed to pound down everybody in the supply chain. So we had quarter-on-quarter price reductions were kind of the norm. Everybody got accustomed to it. Our sales teams got accustomed to it. The whole concept of PPV became baked into the planning for our customers. And what happened is that all worked perfect until it didn't, and it got majorly disrupted. and I don't think we're going back to how it used to work. So the short answer here is our prices are going to come off current highs. They will, but it's not going to be uniform, and we're not going back to pre-pandemic pricing. It's just not going to happen. And while all this is going on, component technology is combining in new and interesting ways, so that what you're getting for the price you pay, actually, there is some productivity improvement there. You're getting a lot more capability, just like you get a lot more capability for your car dollar these days, or a lot more capability for your TV dollar than you used to. But on a part by part basis, unfortunately, the pricing is what the pricing is. The way I when I have this conversation with customers, the way I frame it is, hey, listen, you got basically the advantage of a 10-year hiatus on component pricing inflation. And that was awesome. It was good for your bottom lines. It helped the industry grow. It was awesome. But it wasn't sustainable. And so here we are.
Michael, have you seen the prices go up above kind of nominal inflation rates in the broader economy?
Yes. Yeah, for sure. And because electronics is so pervasive in the broader economy these days, of course, they kind of start to move in lockstep. There is some correlation in terms of pricing in the broader economy. But yeah, it's starting to slow down. I will say that we were through last year into the first part of this year. It wasn't unusual to see, double-digit price increases on a given component, every 3 or 4 months. That definitely, I'm happy to say we've got stabilization, and I think that is pretty universal.
What we're seeing is that everybody jumping on the pricing bandwagon because everybody else was raising prices was last year. This year, it's more tied to raw material costs, inflation costs. We're still seeing it. We're not seeing it to the extent we did last year, but it certainly hasn't stopped. And I'm with Michael. I think that we'll see a little bit of plateauing as we get into next year, most likely. But I don't think we're going to see a vast majority of them try to chase it back down to get share when, inventory is plentiful. And I do think we'll get to that at some point. I don't know how bad or sustained it will be, because I don't think all the capacity is going to come online at the same time for the parts that are hard to get, et cetera. But, pricing is still going up for sure this year.
So what I hear you're saying, and correct me if I'm wrong, is there was definitely an element of, demand was huge, supply was low, so there was some price increases associated with that. But really, in the bigger scale, there was a price adjustment waiting to happen, and that's kind of what we're experiencing.
That's my belief. Yeah,
I agree with that.
Wonderful.
I think a lot of the suppliers took the opportunity to kind of change the price formula with the big OEMs, because before, big OEMs kind of dictated, hey, look, if you want this business, you got to, make the price work for me. And I think that's been flipped. Could it flip back again at some point? Yeah, it could, but we're not there yet.
Interesting. Yeah, that makes a lot of sense. I don't want it to be all doom and gloom here, so I want to give each of you an opportunity. Everyone listening is in the electronic space, either directly as an engineer or in a close relationship to that role. For each of your companies, what are some things that you wish people and wish engineers knew and could utilize? And let's start with you, Jeff.
Okay. Our primary goal is to be the broadest stocked distributor of new products and in total products of anybody, right? We really try to cater to the design engineer that when they're going to kick off their next design, they want to come to Mouser to see, well, what's new? What can I use? What solves a problem that I've been trying to solve, for the last couple quarters, couple years, whatever. And we're a great source of that. I do think that we will see continued creative products coming out of the engineering community. And I give full credit to one of our supplier CEOs, Adam Norwood, the supplier of Amphenol. When COVID really hit and everybody was going to work from home, he said, I think we're going to see a tidal wave of innovation, because if you give the engineers time to really think and create versus having to go to meetings and some of the overhead things associated with working in an office environment, I think we're going to see a lot of cool things come out of that environment. And I believe he's right. I mean, I think the number of new products, I think, is going to accelerate as we get through the next few years. So if I were an engineer in today's world, I'd be very excited about that, because as new things come out, it gives me that creative mindset to say, well, what can I create? What can I build with that? What problem can I solve with that new product coming out of whatever supplier it might be? So that gets me excited about the future of our industry for sure.
Awesome.
Yeah. So I'm in lockstep with everything that Jeff just said. The message I would like to deliver to engineers goes back to this notion of multi-sourcing. It's the way that a customer can best help themselves in terms of risk management. So spend time on multi-sourcing. Make the component engineering thing that I talked about. Make that more of a priority. And I think that's a pretty important step. And then for the purchasing community, and engineering's got to be much more involved with the purchasing community, in my opinion, going forward. I think this idea of resiliency over lowest price. I hope it's prevalent now, and I hope it sticks, because ultimately. It doesn't matter if you have the best price if you can't get the parts to make your stuff to ship and bill your end customer, right? So, and that, right, if you can do that, then I think everything will ultimately rebalance. And engineering has a crazy important role in that.
Excellent, Misha.
A couple of things. I think that one of the easiest one is just focus on software a bit more, because there are just areas where you can very quickly solve manual problems with basic scripting. And I see a lot of electronics engineers not necessarily exercising those muscles there, for a lot of reasons. They love electronics, and they're not necessarily thinking about just how easy it is to glue things together using super ugly code sometimes. Sometimes that's the best way to solve a problem, but also, real design and product level thinking. I still meet engineers that are very zoomed into a particular subset of a functionality that they're building, but don't really have a grasp on what is the customer going to use this for, what are the design trade-offs. And I think it's actually the best time in a long time to be very much aligned with the business, and especially the supply chain. I think some of the older engineers have gotten pretty jaded, because it's been a waterfall process where you do a design, you throw it over the wall. I mean, we meet customers where they fired the design team. Like, the engineers are gone. They're still building the product, but whoever designed it's been gone for 10, 20 years. I think that's going away. We're actually seeing engineers now driving really important projects, especially with like factory automation. The engineers are the ones pulling the water, and all of a sudden they're the ones coming up with ways to go optimize factories, especially in IoT and industrial automation world. The more they understand the business, the more valuable they are, because their designs can directly affect how things work and how things are sourced, to Michael's point.
Are there any initiatives that you are really excited about for either for your company or for the industry at large, looking forward into the next year or 5 years or 10 years? And Jeff, we'll start with you again.
Sure. I'm really excited to see, and this sounds a little weird, but I'm really excited to see how big we can get. And what I mean by that is Mouser is very focused on the design engineer and shipping that design engineer engineering quantities of product, right? We're not trying to be a big volume distributor shipping millions of units every day around the world. But I think there's a wholesale change going on in our industry where that ability for an engineer, a purchasing agent or a purchasing manager, a student, a hobbyist, you name it, to be able to go online, find what they want, do their research, how they want, when they want, not have to be beholden on a salesperson or somebody else to help them, and then be able to place an order easily and get that product shipped. I think we've seen I think we're still in the infancy stages of the change in our industry to be more distributed, kind of coming back to that word. And I think Mouser's business model totally plays into that. We don't care where you are in the world. We don't care what time of day you're on or time of night. We don't care what kind of currency you want to buy in. We try to make it easy for that engineer, purchasing manager, agent, whatever, to find what they're looking for and get it. And I'm really interested to see how much bigger we can get based upon what's going on in the industry at large. Not to mention, I think, as we've seen, in the last couple of years, inventory is really important. People, used to probably take that a little bit for granted when lead times were consistent and, there wasn't not a lot of issues going on. Right now, people are like, wow, I don't really think about it until I can't get it. And then, man, that's that golden screw, as Misha said, is the most important thing I'm trying to find so I can finish this project and get shipped out the door. And I think distributors like Mouser and XCG that hold inventory will just continue to be more important to customers moving forward. So I'm really excited to see what happens in the next, 3 to 5 years.
Awesome. Michael, how about you?
Yeah. So one of the things that I'm working on, I refer to this kind of next generation distribution model, and that's what's got me highly energized. You said it, Misha. In a crisis, opportunity gets created, and I see a real opportunity in this crisis to modernize our model. And the way we're doing that is, I mentioned the engineering services that we're providing. Well, we're coming at this from with a very simple concept, which is it's never too early to start pipelining inventory and building a supply chain for your new project. So with our customer engagements, where we're in some cases doing full product design for them, as soon as we have a bill of material locked down, we can segregate that bill of material into two parts. The piece of it where it's multi-sourced, there are more commodity parts, there's multiple customers in the world for those parts, which means there's less risk. And we can, with little to no commitment from the customer, start sequestering inventory to support their prototypes and get them into production. For the second part of the bill of material is where it gets a little bit trickier, and this is particularly true in micros and of course things like FPGAs, et cetera, where the part is much more unique to that application and that customer. There might not be multiple customers for it. Even there, we can do some risk sharing with the customer to start building a pipeline for those parts. Because what's been happening, and it's part of what's caused the problem that we're all living with today, is it's very sequential. The engineers, they design something oftentimes without any thought or awareness of what they were speccing. Is this a viable supplier? Is the part actually ready to go obsolete? Is it something that anybody actually wants to build? Oftentimes they're going back to a library of parts and designs that they've done over the course of their career without any real thought about, is it just the part they're selecting sustainable? And so they go through all of this and they finally lock down the bill of material, and something else happens. Maybe they build some prototypes or whatever. And then one day it arrives in purchasing. Now and the production planners are starting to work on it. And it's only then that the customer typically would start thinking about, okay, where am I going to get these parts? What are lead times? Are these actually good parts? Are these parts even available anymore? Right? And what we're doing is helping customers do that stuff concurrently instead of in sequence. And because we've got an engineering team now that's attached to what's arguably the largest pile of electronic components on the planet, it's a really compelling value proposition that addresses a lot of the concerns, especially extended lead times, erratic lead times, that kind of thing. So I find that super exciting, and in there is going to emerge something that I think is truly unique and defendable and differentiated in our industry.
Fantastic. Misha, what gets you excited about the future of MacroFab?
two things. One is just the things we're working on. Every time I look, it's really interesting projects, and just the notion of an engineer being able to upload a design, get a couple of prototypes built without ever having to talk to a salesperson. That is, let's be honest, that's the objective of most engineers, is to never talk to sales, but then eventually be able to produce, hundreds of thousands of units and really never leave our platform, and kind of switch between factories, work with multiple factories to build a lot of products. At some point, that's what Michael was talking about, right? Actually have the engineers and the supply chain people on the same platform, seeing the same data, and really being locked in, as opposed to being jammed into conference calls, which is pretty miserable. That's really exciting to see, and because it's all software driven and API enabled, you can build a lot of new functionality with it. We had a company called Altium build our service, manufacturing service, directly into the EDA tool, so they don't want to have to go to MacroFab anymore. They just order prototypes, for example, directly from their EDA environment. But there's also a macro element to it. This stuff is incredibly important, and I think as a country we just haven't been taking it seriously. And the CHIPS Act, I think, is a huge deal, right? Just acknowledgement that we've gone way too far, we've offshored too much, we don't control our supply chain anymore. That's a big deal. And frankly, if we stop there, it would probably be a huge mistake, because it's not the only part of supply chain. Chips are not the only part that needs to make sure it gets manufactured within North American sphere. I'm not even going to say United States, right? But there is a bill, on a Congress floor now to incentivize domestic PCB fabrication. The more you dig into how things are built, the more you can either have a panic attack or really build a plan for how to go do it a whole lot better. Because, like PCB fabrication, right? PCBs come from China and Taiwan. Can't even find them in Mexico, right? There's some fabrication happening in the US, but these are factories owned by, 70-year-olds, and they're selling them off. And, so there's multiple layers of supply chain that are too offshored and just too brittle for us to actually be in a resilient state. And I'm hoping that people finally figured out just how important this is. And I think they finally are. Like Jack White, that's a pretty rocking musician out there. What's the name of his latest tour? Supply chain issues. I think this has finally entered the consciousness. So, maybe Congress gets it. And I think hopefully, even the kids get it these days,
I love that tie-in. As we wrap up, also, avid Jack White fan here, but as we wrap up, we like to do a lightning round kind of at the end of these things. And I was on Twitter the other day and saw someone had found 50 kilograms of 7400 series logic chips that they bought in bulk from someone had it in their garage. If you had $10,000 to buy one type of electronics component just for you to hoard and use, or maybe resell in 3 years, what electronics component would that be and why? And Michael, let's start with you.
Oh, an ARM-based microcontroller. They're like unicorns these days.
Yeah. I tried to buy a Raspberry Pi the other day, and that was a rough one. Jeff, how about you?
Yeah, Michael stole my answer. So my next answer will be FPGAs. They're hard to find right now, and I don't think it's going to get any better for a while.
All right.
Those were my two answers. It was FPGAs and microcontrollers. But then I'll throw you a curveball then. So not related to work at all, but as soon as the sanctions on Russia started coming down, I'm into tube amps, and you'd be surprised how many tubes come out of Russia these days. Not a lot of them are made in. There's kind of a cottage industry of different brands that are now being kind of rebuilt from ancient parts, and they're coming out of Russia. So I'm willing to bet that's going to be a scarce market. Because I don't think they're able to export those anymore.
Yeah, I think all my Nixies came from Ukraine. Now that I think about it, check that box. Last question as we wrap up. We have a lot of engineering students that listen to this as well. Do you have any favorite pieces of advice for those students, or maybe things they should internalize, things they should study, topics they should explore, anything like that? And Jeff, we'll start with you.
I would tell them to just be curious, right? I love that quote from Ted Lasso, be curious, not judgmental. And I think engineering students coming out today stand to, graduate into one of the most exciting times in the electronics industry. So many more things are being electrified, so to speak, that I think the sky's the limit on what things they could get involved with over time. And I think being curious also allows you to not try to architect your career too finely. At least in my career, I've believed that if you're open to new things, cool new things will find their way to you. Versus if you say no to a lot of things, that tends not to happen. So I just be curious.
I love that. Misha, how about you?
I mentioned, software being a superpower. So I'll stick to that. But, my second one is going to be a little bit selfish. We have a pretty awesome podcast for engineers. So listen to the MacroFab podcast. There's about 7,000 people downloading it every week. We got 600 people on Slack talking about God knows what, everything from electronics design to cats and dogs and certainly current affairs. So it's a pretty fun community. And like Jeff said, it's a great time to be in electronics. I wasn't in this industry, but I'm kind of surprised and excited about how dynamic it is.
Awesome. And I love the podcast. I love that gets supported and the community is great there. I agree.
Thank you.
Michael?
Yeah, I would say this is pretty fundamental. Stick with engineering. It is a great place to be. But I would also encourage young engineers to become multidisciplinary, multifunctional. As Misha talked about this, don't go too far down the rabbit hole. Have some range. Be curious about if you're a hardware engineer, or an electronic engineer, be curious about software and firmware. And I think also be aware that there are going to be some ups and downs. I think we're moving into a point where things got a little too heady and companies overhired, and especially in the engineering area. And so I do expect we're going to start to see some pockets of job destruction. Don't let that fool you. There's plenty of work to do for a good engineer, and that's never going to change. So it's if I had kids, and I don't, and they actually listened to me, which they probably wouldn't, and they asked what they should get into in a nanosecond, I would say engineering. That would be my advice.
I'll add one as a bonus. Give people benefit of a doubt. Like I come from a technical background. It took me forever to realize that salespeople aren't liars, and supply chain people aren't knuckleheads, and it's people trying to do their jobs. And like sometimes you just have to not give them a hard time because they're actually trying to help. Believe it or not.
Good point.
Fantastic.
That's awesome. Thanks for that, Misha. That's awesome.
Well, this has been an absolute blast. We're out of time, but thank you so much for being here. I loved your perspectives and having you on here.
Thank you.
Appreciate it. Thank you. Good seeing everybody.
That was Michael Knight, president of the eXponential Technology Group and senior VP of corporate business development at TTI, Jeff Newell, senior VP of products at Mouser Electronics, and Misha Govshteyn, CEO of MacroFab. And thank you to Mouser for sponsoring this episode of Moore's Lobby. If you enjoy this podcast, make sure you're subscribed in your favorite podcast tool, and it would really help us out if you'd share this episode on social. Go check out the Moore's Lobby and All About Circuits social media pages. Thank you for joining me today in the lobby. I'm Daniel Bogdanoff, and I'll catch you next time.